Welcome back to another help video. This video focuses on Unit 1, Lesson 2, specifically talking about the mean and standard deviation. When we are talking about analyzing data, a lot of the times you are going to hear about the mean, and the mean is the average number in the data set. So, for example, think of scores on a test, right? As a teacher, you're looking at a bunch of percentages, and in order to find one percentage that would represent the total data set, the average, you would add them all up and then divide by the number of tests that were taken. That would be your mean. When we are given a graph, your mean is always located in the middle. So for normal distribution, this line right here, where the top of that bell curve is, that represents your mean or your center. Now, standard deviation is pretty complex. And so that's why I have, what the heck is standard deviation? It is a super fancy word that gets thrown a lot. And a lot of the times it's very hard to understand. And so this is my explanation. Standard deviation is how spread apart the data is from your mean. So for example, your mean is here, okay? And under this bell curve is all your little data points, okay? Now, thinking of test scores, we can think, hey, if the test scores are similar or close together, the standard deviation is going to be less spread out. But if the scores are all over the place, like we have kids that really did fail or did really, really well, and then some in the middle kids, then your standard deviation would be more spread apart. Now, for normal distribution, our standard deviation is the same, okay? So the proportions for the normal curve will always be the same for normally distributed data sets. So that means the percentage within each deviation is always going to be the same. So the rule is, the empirical rule, that 68% of our data will fall within one standard deviation. So that is in this light blue or royal blue here. So that's one deviation away from the mean. 95% of our data will fall within two standard deviations. So that would be 1, 2. So this whole bell curve right here. And then last but not least, 99.7% of our data will fall under 3 standard deviations away. So that would be 1, 2, 3. So it would all fall under this right here, leaving these right here being 0.3% to fill right here. Now today you're going to be asked how to use the 68, 95, 99.7 rule, or the empirical rule. And we're going to use it to find probability. Now, whenever I read a problem, I always like to highlight key information. So as I read through this, I will pull out the information that we're going to need. So assume that a set of test scores is normally distributed, okay? So that is super important, with a mean of 120 and a standard deviation of 25. Use the 68, 95, 99.7 rule or empirical rule to find the following quantities. Now, to dissect this problem a little bit, when it says normally distributed, okay, that means this rule can be used. And for all your problems in this lesson today, you will only get the normally distributed, okay? So you'll be able to use the normal bell curve. Our given information is we're given a mean of 120 and a standard deviation of 25. So we can use that information to fill out the numbers below. And how we do that is we know our mean is always that center mark. Okay, so that is our mean. So when our mean is given, that's where we're going to put it. From there, our standard deviation is going to help us get the rest of our little marks here. So we're going to add 25, then add 25, then add 25. On the other side, we're going to subtract 25, subtract 25, and subtract 25. Okay, because each of these lines are 25 away. Now, please don't forget to use your calculator. Calculators are definitely allowed. In fact, they're encouraged. I do have online calculators linked into the homepage of our course. Otherwise, your phone will be just fine, or you can just Google a calculator on your computer. So I'm going to fill this out here. So we add 25, so we get 145. Add 25 and we get 170. Add 25, we get 195. And then reverse it to the left here. We get 95. Subtract 25. Again, we get 70. Subtract 25 again, we get 45. So now we used our standard deviation to label our axis down there. All right, so now that step 1 is done, we used our mean, labeled it in the middle, and our standard deviation to label our graph along the bottom here. The next thing we're going to do is use our empirical rule to label our deviations, right? And those are the spaces away from the mean, right? This is deviation 1, 2 deviations away, 3 deviations away. In our empirical rule, I actually pasted that in right here. We can use this as an example. So now you can see we filled out each of these based off of our given empirical rule. So for today, your practice is going to have you create a normal curve, okay? And what they're going to have you do is take the mean and your standard deviation and fill out these numbers down below, okay? From there, it's going to ask you if given a raw data set or a raw score, okay, how far away is that score from the mean? And in terms of distance, they want you to identify it by standard deviation. So for example, these are test scores, right? And let's say they want to figure out the test score 47. Okay? That test score is how far away from the mean? It is 3 deviations away. From there, it's going to ask you what percent do the scores between 45 and 70 fall under. And you can use this diagram to help you out. So it's in the 3rd deviation, right? So I'm going to highlight that so you guys can visually see that. right? This third deviation, these scores, if you look, that is 99.7. So I would type in my answer, 99.7%. If you guys have any questions, please don't hesitate to email me, schedule a time to meet, or go through your practice problems. Either way, you got this.